Men, and as usual, I use the term extremely loosely today. I got a pair of heads over here. Looks like they've just had a recent valve job done on them. They're a little crusty. They're covered with oil. I think they've been sitting around a long time. Anyway, I had been corresponding with a guy who wanted to dual plug these because he does vintage drag racing. And many moons ago, I did dual plug a head, or at least I experimented with it. I was never real happy with my process or method or accuracy. But anyway, I'm going to give it another shot. I told the guy that I would do these for free. Yeah, big mistake, I know. But anyway, I'm going to dual plug these heads. I'm not an idiot, though. We're not going to do the customer's heads first. I'm going to use this head that's been laying around my shop. It's been a little bit of an experimental head. It's beyond salvageable. So I'm going to use it to experiment on to see if I get it right. There's 2 or 3 methods at least of dual plugging iron heads. One method is to drill a hole straight down the middle of the head and put your plug in here. The other method is to put a hole in sideways, just straight in from the side. The advantage of that is it clears the rocker box without having to modify the rocker box at all. It would seem to me that the best way to do it would be to put a plug on the opposite side that goes in exactly the same angle as the original spark plug. Of course, these fins are all in the way. They're going to have to probably be removed. Well, they will have to be removed for sure. It's critical to get the spark plug hole in the right place. This plug was removed from an engine I worked on that had been dual plugged. And the guy who did it got the clearances all wrong. And imagine a scenario. A guy rebuilds an engine, gets a valve job done, gets a dual plug, thinks it's going to run great. But anyway, the plug protruded too far into the combustion chamber. The first time the piston came up, it whacked the side of the spark plug, bent the electrode over, broke it off, fell down the cylinder. The engine probably ran off of the opposite plug and proceeded to tear up the cylinders. This plug happens to be the plug that I stick in cylinders to fill the hole while I'm painting them. And you could tell from the amount of paint on this thing that it's had quite a few paint jobs done to it. But anyway, I don't want to end up with this in the dual plug job I do for this particular customer. So the problem gets to be, how do you duplicate this angle and this location on the other side? Well, this is my idea. I happen to have a drain plug out of some import car model, I don't know what. It's 14 by 1.25 threads metric, and it is the same size as a spark plug. So I think the first thing I'm going to do is take this out to the lathe. I'm going to drill a hole down the middle of it. And once I drill a hole down the middle of it, of course I'll be able to pass a drill bit through it. And this is the plan. I've got a piece of chunky old steel. We're going to make a fixture. So I'm going to drill a hole down through the middle of it. It's going to drill a hole into this plate. Then if I take the plate and turn it around so the hole is pointing the other direction, bolt it to the cylinder head, I could go back in this way to locate the hole on the inside of the head. And then I'll just drill that hole straight through. Of course, it'll come out in here somewhere. And I'll cut the fins out of the way. I'll face off where the hole comes out, so I've got a smooth landing spot for the base of the plug to seal against, and should be a piece of cake. Of course, I don't have a fixture to use. So step number 1, I'm going to drill a hole in this. Step number 2, I'm going to make the fixture. So this lumpy old piece of steel will be the fixture. I probably don't really need to, but I'm going to put this on the milling machine and square it off. There's no two edges that are square on it. It really doesn't matter, but it just bothers me that it's not square, because somewhere down the road, I'm going to wish it was square, and if I don't do it now, it won't be. So let's go drill a hole in this, and let's put this on the mill and square it up, and let's start making a fixture. Step 1, successfully accomplished. Okay, on to step 2. I'm sure it's going to be a little trickier than step 1. This does not have to be any particular size. It just needs to be big enough to pick up the 4 head bolts. So we're just going to make it square, that's all. I got one little tiny corner here that didn't get touched yet. Close enough for me, though. I now have 2 sides that are parallel. Neither this side nor this side is square to this side or the other side, so I got to flip this piece around to get it to square up. All right, part 2 is done. Let's go back to the clean shop and do a little line out on it. Okay, so the question gets to be, how do you measure a rectangle whose edges don't exist? I mean, the rectangle is in the center of these holes somewhere. So let's do it this way. Okay, let's call this 2.190. Yeah, 2.190. from here to here. The holes are 0.460. That is the diameter. Therefore, the center is 1/2 of that, the radius. So from the edge to the center is 0.230. 0.230. So we got 2.190 plus 0.460, 2.650 divided by 2 equals 1.325. So let's set that up on a caliper. And let's just transfer that dimension. If I did that correctly, these two holes, actually these 4 holes, should be centered over that line. And they pretty much are. Okay, so let's go the other direction. And the other direction I come up with 2.690. Excuse me, plus the 0.460. I come up with 3.150 divided by 2. Come up with 1.575. So we'll set the caliper again. 1.575. Mark it off. Draw the other two sides of our rectangle. If I'm lucky, and I'm pretty close, the holes end up centered over the corners of the square. So this is centered in this block as much as it needs to be. Now, having done all this, I'm not going to drill the 4 holes. I'm going to drill 1 hole. I'm going to drill and tap 1 hole. I'm going to bolt the head on it, and I'm going to use the head as a template to drill the other 3. Why did I go through these gyrations? Well, I wanted it to end up centered. So I'll drill the 1 hole, bolt it down, use the bolt holes in the head, and I'll just center them over these other points. That way I know it's parallel to my block. That was the goal anyway. All right. Got my, what's going to be my dope plug drilling fixture. Clamped up on a couple of parallels. I'm just going to eyeball the hole to get it lined up. I got 1 spot here has been center punched. You know, a guy could use a center finder and things like that, but there's some wiggle room on these head bolts. The holes are actually bigger than the bolts, so there's a little bit of room to twist this thing around. But anyway, we're going to call that good. Let's drill it. Okay, Harley head bolts are 7/16 20 go figure out what size drill I need for that. Be right back. Okay, chart says I need a letter W. Let's bolt the head on there and drill some more holes. I was pretty damn close to my layout. Yep. All right, here's my rant on taps. You guys have all been to the discount tool place. You know the one I'm talking about. And you can buy a set of taps, 67 taps, maybe more than that, maybe 120 taps, fractional metric, pipe thread dies, for $37. Junk of the worst kind. Those things are only useful when chasing threads on an already tapped hole. For making new threads, totally useless. They just don't cut well. This particular tap is, and I bought many of those sets over the years. I finally broke down and bought some quote-unquote good taps. This happens to be a Travers Tool Company, TTC, house brand. The difference is night and day. I bought a set, I don't remember how much it cost, but it was probably $250 or something like that for the basic thread sizes, and that would be like maybe a number 10 to a ½ inch, coarse and fine, and a set of dies. All the difference in the world. These things are cutting through, this one is cutting through this chunk of 5/8 or 3/4 inch steel as if it were butter. It doesn't get any better than this. If you really want to enhance your threading experience, go buy a good tap. Anyway, that's 4 for 4. This part of this project is done. Let's go back into the clean shop and figure out the next step. Okay. Now we're getting to the part that's interesting. Well, you know what? Let's do this first. Let's make sure the bolts all go in the holes. Good, my holes all line up. That's a good thing. Okay, here gets to be the good part, is this drain plug modified with the 3/16 inch hole down the middle goes in the spark plug hole. I need to be able to put a drill bit in that hole and drill a hole at that angle through this plate. Well, of course, it ain't gonna happen. So what I've got to do is figure out about where this drill bit is gonna hit that plate, and then put the plate in the milling machine at an angle and drill a flat spot so I could get a drill started. So, I don't know how well this is gonna work, but let's do this. Let's take this chunk of steel. This side's a little smoother than the other side. And let's just put some Sharpie on it. Then let's take this chunk of steel and bolt it to this plate. All right, so let's just stick this drill bit in that hole and hopefully scuff up the area a little bit. All right, I think I got it where I want it. Well, I hope that's enough. Let me flip it around to the other side. All right, let's see if I got lucky and got my locators, my spot faces in the right spot. Let's put a little black marker on them. And let's bolt the head on. Let's see where we land. That sounds good. All right, We ended up right there. That'll work. So I think this one will work too. We're going to bolt this back on and we're going to drill all the way through. Fuck, that popped out of there already. Son of a bitch. Not nearly as hard as I thought it was going to be. Let's flop this around and go the other direction. I drilled out my spark plug bushing hole to 3/8, and I'm going to go drill one of the holes in my fixture plate to 3/8. Nice. Let's see how we make out here. Seems like it went through. Let's see what the hole looks like. All right, we got 2 holes. I've been dicking around with the fixture and the junk head to prototype this on. This is the real head. This is a customer's head. So we're gonna do ones that count, or we're gonna do work that counts. So the first thing I'm gonna do is I'm gonna cut the fins off that are gonna be in the way, and I'm doing this so that when the drill bit breaks through, it won't have to go through all these fins to, get a clean break. It'll come right out of the head. So let's get rid of these fins I'm not gonna need. That's exactly what I wanted. Good deal. And let's clean up a little bit over here too. All right, that's done. Okay, let's bolt the fixture on and drill the hole. I'm leaving one head bolt out so that I could run my cylinder hold down mechanism, my cylinder head hold down device in the remaining hole. Nice. Time to reverse the fixture. Standard 3/8 drill, just barely long enough. Okay, one done. Let's get the other one drilled. Alright, this is what I decided to do. I got a 3/8 inch hole drilled in the head. I got a piece of hot rolled rod. This is the deal I use for setting up seat cutting. So I'm going to zero my digital protractor on the spindle. And I'm going to zero the left-right vertical on this angle plate. Zero. All right, I'm going to snug this down just a little bit. I'm going to check the opposite axis and zero it up. Well, let's put it on the spindle. Re-zero. And let's zero it up over here. Okay. That zero on the opposite axis, let's just double check it. Spindle is still zero. Let's check this way again. Re-zero. Zero. Good deal. Tighten this up some more. Good deal. Don't need this anymore. I got a 3/8 inch collet in the mill. And of course we wanted to slip over the 3/8 inch rod without deflecting. That's nice. We'll lock it down. get the collet out of the way. First thing I'm going to do is put a end mill in there and flatten off the seat for the spark plug. And I'm doing this first so that the tap drill, when the tap drill goes in, it will have a square surface to sit against. It won't be pushed off center by the angle of the hole there. Okay, tables are locked down, everything here is tight, mill head is tight, so we're ready to do a little seat flattening. All right, get the drill out of there. Let's put the spark plug tap through there and tap the hole. Okay, one set of threaded holes. All right, I got the head turned around on the angle plate. I've just eyeballed the drill over the newly drilled spark plug hole. And in order to unshroud the plug, I'm going to peel the threads off, about the bottom 3/8 of an inch. Okay, that's all that needs. Now I'm going to go in with a countersink and I'm going to chamfer the edges of the spark plug hole. Okay, the drill chuck just barely clears the head, and that's a good thing. Okay, I'm going to call that good to go. And I'm now using my drilling fixture as a pallet to hold the head on the angle plate. And I have to do that because the holes, the cylinder head bolt holes are outboard of this machined surface. So if I were to just tighten it down on the cylinder head bolt holes without having this there, it would tilt the head one way or the other. So the pallet catches the flats that the rocker boxes sit on, and that way I could get a firm, square seating in order to do the countersunk operation. Okay, here's the inside of the head. The inside work is done. Here's the new spark plug hole. I've peeled some threads out of the leading in part of it there to unshroud the plug. I went in with a 9/16 drill and opened up a little bit. I also chamfered the edge here to also unshroud the plug. You know, if a guy wants to port and polish and fool around with it, he can. I don't know that it's going to make much difference. This is the bushing I made to align the pilot drills in the center of the old spark plug hole and allow me to drill across into the fixture plate, and then the fixture plate to drill this hole. I've put this in the original spark plug hole, and I cut it off flush with the outside of the cylinder head. So this length of threads and that little protrusion on the end, that's how long or how deep the spark plug hole needs to be. So what we're going to do is we're going to put this in there. Snug it down a little bit. Put this back in the milling machine and then mill the spark plug seating area until it is flush with that pilot bushing. And then this head will be done. So let's put it back in the mill and get it wrapped up. All right, and I'm right there. I'm just a little shy of hitting it, probably, I don't know, 15, 20 thou. I'm just going to leave it there. I'd rather have it, I'd rather have the plug not quite set deeply enough than set too deeply. If you set it too deeply, you can hit the piston. So I'm just going to leave it right there and call it good to go. This one's done. I am out of here for now. See you in a little bit, though, for kind of a final wrap-up. Okay, here's the wrap-up on this project. And I want to get you in and get a couple of close-ups so you can see what's going on. Here's the finished head. Here's the added spark plug hole. Here's what it looks like on the outside. Let's put a plug in there. Let's put two plugs in there. Okay, here's what you got. Both electrodes are safely below the surface of the head so they won't get smashed by the piston. You've got good exposure. They're not shrouded by the depth of the spark plug hole. I'm really happy with this. This project went pretty well. Pretty well indeed. Let me grab a rocker box and show you one concern. Okay. Here's a rocker box, and I'll show you the one problem or the one concern with putting a plug over here is the plug is pretty well shrouded by the rocker box. In order to get it in and out, this area is going to need to be relieved. I could do that for this customer, but he didn't send me any rocker boxes, and I told him I would do it for free, this shop for free, and I did it so I could prototype this arrangement. So, notch out the rocker box. Other than that, this should work great. Even with that, that's not that big a deal. Your only concern with the rocker box, with doing that modification, is there's an oil passage drilled straight between these two plugs. So you will be well below that when you notch this thing out. Something a guy could do with the Dremel tool. So I'm going to let the owner do that. I just don't feel like doing it. Well, he didn't send me the rocker boxes anyway. But anyway, really happy with this. This worked out well. Really, really worked out well. Couldn't be happier with it. Kind of a pain in the balls. Well, you know, it's not really kind of a pain in the balls. It really, the actual work of putting the plugs in, the extra plug-in, is not that bad. The work was building the tool. You know, now that I've got this jig set up, this fixture set up, I can repeat these results as much as I want. And I did a little refining on the tool off camera. I knocked all the mill scale off of it. These screws were cut to just the right length so that they could go through these holes, go through the T-slot on my little angle table, and into the T-slot without bottoming out. So I didn't want to lose these screws. So I drilled and tapped a couple of holes over here to keep track of the parts. And then the bushing for setting the spark plug thread depth, I didn't want to lose that either. So I drilled and tapped a hole over there. Spark plug thread size, 14 millimeter by 1.25. Anyway, that's it. Really happy with this. Was kind of a fun thing. I've been procrastinating on this project for like 10 years. I tried to do this once like 10 years ago, and my skill, my equipment just wasn't up to it. But I've got a tool that's reusable, results that'll be reproducible anytime I do it. So very happy with that. And you know what? With that, I am out of here. Hey, thanks for watching. Please subscribe.